The 2-opt is a heuristic for the traveling salesperson problem. This problem is trying to find the shortest path between all nodes without repeating an edge. The idea behind the 2-opt solution is that two intersecting lines are actually not as efficient as two straight lines. In this example, we have 4 points spaced 10 units apart. There's a connection between 0, 1, and 2 and 3 that intersect in the middle. If we calculate the distance between those 2 points, it actually winds up being 14 units. However, if there were no intersection, the distance would be 10 units for each edge. Because of this, we know that if we were to switch the edges, our final path would be more optimal than it currently is. Using this concept, we are able to implement an optimization program to help us create a better path. This project consists of several files, most of which is help sort out the data, and others to actually run the algorithm. The one you see now is the main.py, which starts the algorithm and also includes the file. Next you'll see the TSP48, which houses the GPS coordinates of all 48 continental states in the US. And finally you'll see a TSP small, which houses just a few nodes for basic testing. Because we must find when two lines intersect, this becomes a linear algebra problem. NumPy is a great library to use when you must do mathematical calculations. It actually solves a matrix without us having to do many calculations at all. Furthermore, Shapely helps us to see if the point of intersection is actually within the realm of possibility with the given edges. Next, you will see the 2-opt class, which actually does all of the brunt work. To run you through the code, here's how it basically works. Upon instantiation, the 2-opt class generates a random path between all nodes in the list. Network X makes it very easy to generate a path on the graph due to their really great API. The rest of the functions are mostly used to sort of check the solution after the swaps have been made or as they're being generated. Finally, you will see the sort function, which actually begins sorting the graph. All of the code used in this project will be available on the GitHub link listed below. At the time this video was published, the function doesn't actually get the best 2-opt solution. There are some problems with the constraints that I just quite haven't had the time to work out. My goal was to make an animated version of it, which I did succeed in doing, which we will see here in just a few moments. Finally, we actually get to see the algorithm in action. This is the TSP48 mentioned earlier in the video. Bit by bit, the diagram becomes less and less cluttered as the intersecting lines sort of iron themselves out. Once again, I must reiterate that this is not a fully functioning implementation of the program, but it does show each step and iteration of the function as it begins to work. This section was purposely slowed down to help show each iteration of the function. This example was not slowed down. We can see that it quickly irons itself out. However, it still has a problem with the intersecting line in the middle. Hopefully in the future, I will be able to fix this problem and produce some fully functioning 2-opt solution. I hope this video has been helpful for you in your understanding of the 2-opt solution. If the 2-opt intrigues you, you might also check out the 3-opt or the multi-opt solutions. Once again, thank you for watching, and I hope you enjoy this video and enjoy the code. Thank you.